Welcome to MyProjectBazaar.com. Let we discuss about the process, a class-based approach for medical classification of chest pain. Let me see the abstract of the process, a class-based approach for medical classification of chest pain. Data mining is one of the most motivating areas of research that has become increasingly popular in health organizations. Data mining plays an important role for uncovering new trends in healthcare organizations, which in turn helpful for all the parties associated with this field. The mining of the input data is the most important task in all the type of the data management system. Association rule mining is commonly used for mining the input data. The relationship between the attributes were estimated and based on the input data can be represented in a binary format. The rule-based mining can be more useful in the medical research in order to effectively analyze the symptoms and treatments for the diseases. In the proposed approach, a class-based approach is employed for the classification of the data based on the order rule tree. For the generation of the rules associated with mining is employed. The process is done in medical dataset. The chest pain dataset is related for this process. The chest pain is normally identified based on the attributes like age, sex, serum cholesterol level, blood pressure. The main objective of the process is to classify the data based on the ordered rule tree. To generate the rules for the classification from some association remaining to prove the rules based on the each attributes of the input data. To check a redundant rule for the input database and to identify the class of the data in order diagrams. Now to diagnose the chest pain. To employ order rule based approaches for the identification of the arrangement of the attributes. Let me see the flow of the process. First, we select any one of the input hard data. First, we select any one of the attributes from the data. The attribute selection process is based on rule mining, which defines the single attribute set for all the classes into smaller one for every classes, which limits the searching dimensions. The domain knowledge about the diagnostic tests for a specific disease helps selecting the specified regions associated with the disease. Thus, the second stage selects a uh, process which contains the attributes which are most useful from there, or else we can select any one of the attributes in from the user itself. After that, the frequency identification process. In the frequency identification process, the number of occurrences of the each attributes were counted and they were sorted in the descending order. Further, the rule mining processes were applied. Here, the rule mining processes refers to we have to define the rules for the process. So, rules like rules which are based on the uh, attributes which is given as the input. Attributes like age, age, sex, and the pressure rate and everything of the input data obtained. Finally, the OR tree is formed. Ordered rule tree is formed based on the generated rules. The ordered rule tree classifies the input data set into different regions, which is based on the arrangement of the selected attributes in the process. The classification gives the different classes of the input images, which is like the name of the heart disease identified or the parameters which is needed for the heart diseases can be identified. Finally, the accuracy of the process is measured in order to find the efficiency of the process. Let us see the running procedure of the process. If you want to run the code, select the file main.m which is present in the source code folder. Right click it and click on run file. You will get the process executed. This is the input hard dataset which is obtained. Chest pain dataset. This contains several attributes. From these attributes, we generate new attributes. For that, we first identify the frequency of each of the attributes and sort based on the descending order. This is the input data which is sorted based on the identified frequency. These are all the newly generated attributes for the process. With these attributes, we classify the process. So, with the help of each of the attributes, we first classify. So, first with the help of the serum cholesterol, which is the first attribute, we classify the data based on normal or heart pain data. Like that, we classify each and every one of the input data that we have obtained. Similarly, with the help of the maximum heart rate, we classify as normal or heart pain. Similarly, with the help of the old peak attribute, we identify the heart pain or normal data. Similarly, with the help of the major vessels, we obtain. So, for each of these processes, the ranges were identified based on the data set. This is the resulting resting ECG result. This is the classification based on the slope of ST segment. This is the class identified using chart. This is the class identified using blood sugar. This is the class identified using exercise-induced angina. So based on all these classifications, we obtain the classes. After that, these are all the attributes that is present in the input data set. So we select any one of the attributes with which we can classify the patient data. So we first select any one of the attribute within 10. After that, the classification is identified. So this is the class identified for the input attribute, and this is the error rate for the input attribute measured. From the result of the input attribute and the previous attribute, we identify the most relevant classes and we classify the data set. After that, we select any one of the patient, which is we have the data of about 1 to 270 patients data. So we select any one of the patient for the identification of blood, heart patient or normal. So we select any one of the patient. So the person is suffering chest pain. So and the accuracy of the classification process is measured and it is displayed here. Thus, we are taking a heart pain dataset as input, and with the help of the heart pain dataset, we classify the data, and finally we measure the performance using the accuracy of the process.